Hello everyone, this is Space Cafe Podcast and I am Marcus. SpaceX needs no introduction, right? It's the epitome of space travel at the beginning of this 21st century. It doesn't have the grandeur of the 20th century NASA, but it has the youthful courage and audacity already. Move fast and break things was the unholy motto of Facebook back in the day. And it kind of also fits SpaceX's early years. Small, agile teams, fast decisions, fast iteration cycles, fail, learn, succeed, repeat. Today, SpaceX is exactly 20 years old and looking back already on an extraordinary career. And believe it or not, of course, it all started small at some point, and current CEO of satellite communications company Mynaric, Bulent Altan, was one of the first employees and later vice president of SpaceX. Without him, Starlink would not be around today. Welcome, Bulent, to the show.
It seems like we have pretty good bandwidth. Are you on Starlink?
I'm not. I am actually on our office connection, but I think I'm about to do a Starlink just as a backup. You never know.
Say, a super nerdy, curious question. How does the bandwidth compare to your usual fiber connection you have, like 200 megabits?
It's a shared bandwidth situation. So you probably against a fiber connection, which is a star network to the local connection hub. It's a shared bandwidth, kind of like a cable network. So the user amount and what they're doing at any given time has an effect on you as well. But overall, it is a high bandwidth solution. Starlink seems to be able to hit speeds of 150 megabits per second from what I can hear and see from a couple of friends. I haven't really had the chance to use it myself enough to actually have an opinion, but it seems like they're doing quite well. And it's really a function of the number of satellites that I deploy as well. At this point in time, they're stuffing the gaps just to increase bandwidth, not to add more coverage. So, yeah.
Mm-hmm. Sure. What do you think about Starlink? I can see like that Starlink is pioneering that field, but now like it seems that each and everyone wants to have their own constellation doing similar things. Does that make sense? Does it produce like the super bandwidth, or where are we headed with all this?
I think if you look at the history of communication and if you look at the history of bandwidth usage, the growth of it is exponential, the least. If you look at bandwidth being served by ISPs, we see more and more ISPs going into that business. We see each one of them increasing their bandwidth allocation per customer. And that's no different than in the space business. We're going to see constellations come online for different customer segments. We're going to see communication strategies and end user terminal strategies being decided upon, and the constellations being tailored for that. So I don't think there's a one size fits all, or even if two constellations are the same, I don't think there is a limit to the demand. So yes, I think there will be many constellations. There's going to be different user terminals. I can definitely see that. One's for really high bandwidth for household or for very much a commercial application in a fixed location. There's going to be, I'm quite sure of that. There's going to be automotive solutions that really are driven by, I want to say, a medium bandwidth, but from an installation cost very low. So I see a lot of constellations being deployed and playing a big role in the future of communication.
Mm-hmm. Mm-hmm. Almost exactly a year ago, I had my Space Invader moment. I'm here in Vienna, a pretty urban area, was sitting with a friend having a beer in his garden, looking up into the sky. Then I saw that Starlink Space Invader constellation. that was pretty awesome because I saw it for the first time. So my friend was kind of like really scared what was going on. But speaking of that urban area I'm in, would there ever be a situation where I would use Starlink over my fiber cable? Because we have fiber cable infrastructure. Would it ever make sense here in an urban area to use Starlink or another constellation?
Depends on the constellation we're talking about. I don't want to really concentrate on Starlink per se, but on the satellite constellations. I think if you look at the urban environment and you look at a fixed asset like your home, like a factory or an office or whatever it may be, I think the fixed installation, the terrestrial solutions that exist will be the right solution for you. I think you need to leave the city center and go for a lower population density for the broadband connectivity to make sense. But if you look at other use cases, it may be, for example, secure connectivity. Let's face it, you're in the middle of a city, but you are in a embassy. You want to communicate maybe with a bank that is doing high secure communications, and it thinks that being in a single network worldwide or being in a telecoms network that is not being deployed by another country, then in that scenario, even in the city center, there is a use case. There's another use case, of course, of mobility. Mobility in itself is a use case that could be served by satellites quite well. There are many use cases we see for satellite constellations where the communication is one-to-many. A really good example is, for example, a firmware update. If you do it via, I want to say, an LTE or a 5G connection, you end up with one-to-one communication, where in satellite you could do a broadcast of the firmware, be a little bit more sustainable with the way we use bandwidth, and deploy firmware updates that way. Maybe you play it 5 or 10 times over the course of a day, but not a million one-to-one connections, and you do your firmware update that way. In that case, satellite connectivity in the middle of the city makes sense. So it's a nuanced answer to say that satellites have a wide satellites and satellite constellations have a very wide use case, and it isn't just tailored just for the low population density areas.
Sure. So you were the vice president of mission assurance for the Starlink mega constellation. So what was it like when you heard about the headwinds Starlink was facing from astronomers complaining that it was blighting the sky? Was it ever something that you guys considered?
I've been now outside of SpaceX since the end of 2017, so I don't want to make any comments in the name of SpaceX. All of this headwind and discovery of the Starlink satellites being very visible in the night sky came after I left the company. So I would say, from my personal side, I would say I was a little surprised that, given the satellite size, that there was such a big visible factor to the ground. I'm quite happy with the way, now as an external party, I'm quite happy with the way SpaceX is picking up an active conversation with the astronomer community. It's going to take a certain amount of dialogue between the companies and between the involved parties to find an acceptable solution. I think we can't have the solution be, okay, low Earth orbit is not usable. You have to go always about 1,000 kilometers if you want to do any constellation. Let's face it, there is the limits of physics and the limits of the speed of travel of light that dominates latency. And if we just completely forbid the use of any constellation below 1,000, we're not going to get anywhere. It just, we have to find the right solutions to that. And I think they're doing that. There is quite a bit of work happening on constellations to decrease their reflectivity. I'm happy to see that. And there's going to be work, more and more of it. And as technology progresses, I also expect that the constellation satellites will get smaller, their power consumption getting smaller. And of course, with the solar panel being smaller, your reflectivity gets smaller as well.
Sure. So in order to understand your work currently as a CEO in Mynaric, we need to go back in time. in order to understand your current situation and your current position. So let's go back to 2004. You were one of the first employees at the then newly established SpaceX. So how did you end up with that company in the first place?
So the first time I heard about SpaceX, I was a student at Stanford. We had a student group. Me and two friends were part of a student group that was building CubeSats back then. We were under the leadership of Professor Twiggs, who is attributed to inventing CubeSats. And with him, we were developing some of the earliest CubeSats. We were very hands-on people. This was in 2003, 2004. And as a friends group, we heard about Elon and his idea around SpaceX. When he came to Stanford to talk about it. And back then, there was really not a commercial spaceflight. So there was a lot of skepticism on campus of what that could be, even from the side of from the academic side of the university. But for people like us who got their hands dirty, really very often, and we loved doing that, we said this sounded very interesting. Our career outlook included mostly very large companies where until you got your hands dirty with hardware, it would have taken a very long time. So we decided it was better to just try our luck with someone who really needed someone to get there and get things going fast. So all three of us joined the company back then, and it was in the end of 2003 for the first one of us, and the other two, me and my other friend, joined in 2004. And from then on, we exactly found what we were looking for, just an environment where you got stuff done.
What was SpaceX like in those early years? Was it that typical garage style, very dynamic, very young company?
I think, yes, it was garage style when you think about those things. It was very dynamic, long hours, decisions being made quickly, hardware in the foreground, mission and getting to the launch pad being in the foreground. We really didn't dwell too long on a single decision that would have cost us even a few days. We just made decisions and moved on. We worked very iteratively, and it was challenging. It was very challenging because there wasn't that much knowledge base one could lean on. People hadn't done a new rocket development in a very long while, and the ones that have done it were already retired and out of the workforce. So it was exciting. But that being said, one also associates garage shops with a little bit of messy working and whatnot. And that's you can do only so much of that in the aerospace world. Let's face it, it's a cutting edge technology. It has to work. As one says, a rocket has a million ways to fail and only one way to succeed. And you couldn't afford to be sloppy. So there was a certain amount of regimen just because we were in the aerospace sector as well.
Fascinating. So how do you approach such a task like developing a new rocket? I mean, like I imagine you have a bunch of young kids, of course, experienced people. You got out from Stanford, others come out of similar places, but then you were asked to come up with new solutions when it comes to rocket making. So you get together, you do your roundtable discussions. How does that work? I mean, like, does someone come in with a manual how to build a rocket, or how does that work?
I gotta say, building rockets is actually quite a linear process. At the end of the day, the basic principle is quite easy. You have an engine that pushes you from the bottom, and you have to guide the nose towards where you want to go. And there's actually a joke about it, but one says, getting to space is easy. You aim for Earth and you miss it. But no, actually, there is the actual principle is, and the actual machine is an easy one to understand in terms of complexity. The devil is in the details. So when you're doing a top-down design of a rocket, the elements come quite easy when you do a small little functional diagram or something. It's easy to put together. The devil is in the details, comes in the form of you have to deal with really high dynamic environments, big vibration, big thermal, big a lot of shock events. The propulsion people have to work with a very intricate engine that have to deal with the fact that amazing tolerances have to be there. So that's where things get complicated. So the early years really looked like we would just go to a whiteboard and you could really put together the elements quite easily. Then you had to unfold what making that single box entailed. And that kind of work can be done iteratively. So you build a flight computer, put it on a shaker table, you gather your experiences, what breaks, what doesn't, and you take that further.
Was there like a Falcon Zero, a test version of the first iteration? Is there like a small thing you would build, or do you go for the real thing right away?
I think Falcon 1 was our test thing. We did 5 of those launches. The first 3, of course, failed, and then we learned how to build a rocket along the way. I think Falcon 1 was for that time, the smallest rocket one could build to be still a minimum viable product. And that's what we did. And the success was the fact that we taught a company the processes, the engineering, the amount of things it took to build a rocket. And the success is apparent in the fact that Falcon 9 is one of the few rockets that makes it into the launch pad so quickly, and then becomes one of the only ones that makes it into orbit on first try. But it needed to base itself on the experience of Falcon 1. But that was our early one. That being said, elements of the rocket, the engines, the computers, the structures, the separation systems, whatever you want to call it, they went through multiple iterations. And that's what was exciting about it. I remember my first day on the job, I sent out that day on my first day on the job a PC board for manufacturing because I want to get experience right away. And I had it a couple of days afterwards in my hand and learned everything I needed to learn. And that was very important for the company.
Fascinating. What was working with Elon like?
I'll say it in the most open way. I think it's fantastic to be working with a person that enables that level of innovation. He has very clear directions to the company. He gives you the resources. He is demanding and challenging, but that's rightfully so because the goal is so big and so important. And as an engineer, it's an absolute luxury to be in an environment where for the things that you love doing and you spent your lifetime until then getting ready for, you are given the place, the resources, the finances to do so.
I heard about a James Bond moment way out on a Pacific island, and there was an interesting situation I heard. Could you go back to that moment?
I think you're referring to us saving the rocket for the fourth flight. So yes, you're absolutely right. We did our first launches, actually all of our Falcon 1 launches out of an island called Kwajalein, which is in the Marshall Islands. Think about it as most people cannot place it really on a map because you can't really see it from a map. You have to really zoom in. The islands are tiny. There are islands of an atoll. If you fly from Los Angeles to Hawaii, and if you double that distance to fly another 5 hours, you end up there in the middle of nowhere. It's like
10 hours.
It's about 10 hours from LA. Yeah.
So, okay, to produce an understanding for us, if I fly from here, from Vienna to somewhere in 10 hours, I can go somewhere in the middle of the United States. So it's quite a distance. So there's this huge distance still available off the coast of Los Angeles. So this is mind-blowing already.
Yeah. And if you do it in the direction you do it, which is pretty much southwest from LA, you end up in the middle of the Pacific. You open up Google Maps and you type in Marshall Islands and you zoom out, you only see water. And that's exactly it. When you're actually taking a boat between the main island and our launch pad, you had to take a boat. And there were moments where you didn't see any landmass. And it was interesting. It felt like open ocean, and it was open ocean. So anyways, it was a remote island.
Do people live there?
They do. The Marshall Islands is a nation of multiple atolls, and Marshallese are distributed amongst those atolls. And we were in the Kwajalein Atoll. Our island was the Omelek Island. The main island is Kwajalein Island, but there is multiple islands that have inhabitants with the biggest number of inhabitants on the neighbor island to Kwajalein called Ebi. And that's actually quite a high population density.
Wow. And there you had your little rocket launch pad.
Correct. So on another island...
And you wanted to bring your rocket to that place.
Excuse me?
And you wanted to bring your first rocket to that place.
Yeah, it was a good place to do our first launches from. It was an easy place where there wasn't that much going on around us. There was no press or anything. So we did our first launches out of there. It had logistic challenges, as you can imagine. Even if it takes 10 hours with a plane to get there, anything larger to ship there had to come via ship, and it wasn't really one of those major ports where you have a ship coming in every day. It was about monthly that you would get a shipment. So we had to deal around those logistics issues. The first 3 launches, we built the launch pad from scratch. We had to deal with doing operations in a place where if you forgot a screwdriver, you had to get it from mainland. So it had its challenges, but we were able to launch. Those first 3 launches didn't succeed out of various reasons. But finally, when it came to the 4th launch, we had our last chance to make it into orbit. But the logistics issue became an issue in the fact that it would have taken too long for the rocket to get to the launch pad. And we decided to ship it via plane to Kwajalein, where the U.S. Air Force helped out and allocated a C-17 for that transport. And we loaded up the rocket and flew along with it on that C-17. It was a great moment, and just because of the distance and the weight we were carrying, we had to stop in the middle in Hawaii. And exactly during that landing, our rocket decided. As you would imagine, just like any water bottle you take on an airplane, to start actually crunching inwards, pretty much because of the pressure differential, and started crumbling. And it really that was the James Bond moment where we had to tell the pilot to go back up to equalize pressure, and had to find out how much time was left, which was about half an hour of fuel. And we had to come back down and find a way to equalize pressure faster. And we started opening up holes and let the rocket breathe. And that's what we did in flight. And that was an interesting experience.
So, of course, all black jumpers, I guess, and you took out your knives. So were knives allowed on board?
Interestingly, yes, the rocket was covered. The rocket was covered in a shrink tube to keep it nice and clean and whatnot, but it also kept us from accessing it. So when we had to get past that shrink tubing or that protective layer, we had to cut through it, and it was amazing that so many engineers pulled out a knife in the middle of a plane, but. Again, this is another commercial flight, right? So we had our tools and everything with us, at least the limited set we had. Yeah,
absolutely. So the distance you needed to travel. So if someone forgot something, that person wouldn't just get away with buying a round of beer for the crew, right?
No, it had to be a little bit more. Actually, we had an incident like that where we had a failure of one of our boxes, and it required 2 capacitors, and it took multiple flights, me flying back to LA, someone else flying to Minnesota, picking up capacitors, us meeting in LA, and then flying to Kwajalein, all in all for, I think, 40 cents worth of capacitors. So yes, logistics was a big issue.
So what became of that rocket? So you brought it successfully down to the runway, you landed it safely, it crunched only a little bit, but what became of that rocket? Did it ever fly?
Yes, we brought the rocket all the way to Omelek, to our island in Kwajalein Atoll. We did a damage assessment. We looked at the runway we have, meaning for the company, and we decided we had to go really quickly, repair the rocket, and get to orbit as fast as we can. And that's exactly what we did. Some amazing people work there and still work there. We put our resources together and we did the fastest we can, strip down our rocket, repair any damage that was done, mostly structural damage to the inside of the rocket. We put it back together and flew that rocket, and that became the first ever successful launch of SpaceX.
Wow. I mean, like, that was the most critical launch ever, because if it had failed, there wouldn't be a SpaceX around today, right?
That, at least that looked like that. It was definitely a critical moment for the company.
How does that feel like within the crew? Do you watch that launch, or do you, I don't know, dig your head somewhere in a hole and wait for it to be over?
Interestingly, I never had the luxury of not watching a launch or not being involved. One of the things actually interesting is I have never seen a Falcon fly with my own eyes, because every launch I was involved in, I was always in the control room. So I never had the luxury of looking away. Yeah, sweaty palms, heart beating. It's a surreal moment. Every second tends to just stretch out, and that time until stage separation, until the second stage lights up. And then it just, that constant feeling in your stomach, waiting for something bad to happen because you've seen it 3 times. But then when that engine shut down on first flight, it was a fantastic surreal moment. And that's what makes, I think, that's what makes the space business so interesting, because you work really hard, just like me and many other industries, but you have these tremendous singular moments in it that signify your contribution to the industry you're in. And may it be a launch, may it be a deployment, may it be first signal from a satellite, may it be someone landing on the moon and doing their first step. Moments really define space and how we do business in space, how we do things in space, how we explore space. And that's what gets us going, sometimes through those really grueling moments, that those very long work hours.
Sure. You know what really fascinates me and has always fascinated me about that company is that SpaceX found a way to make failure a success. So whenever a rocket blew up, to me as an audience, I felt like it was still a success because one could learn from it and make it better next time. So was that just a good marketing tool to me on the outside, or was it a disaster on the inside? So how was that?
No, actually, I think failure belongs into any cutting edge technology, cutting edge company. Failure, learning from failure and reiterating was a big part of SpaceX. And today you can't really think about the space business without it. If I look at what we do at Mynaric today, we are working on yet another cutting edge technology. Optical comms that is mass produced, that is affordable, that is as capable as the one we have, pushes the boundaries of all the underlying technologies as well, from electronics to optics to manufacturing technologies. And trying to go into these domains with a naive thinking that from you're going to be able to just on paper design it and have a concept and then immediately have it work on the first try is just wrong. When people coin the term failure is not an option, or when the people say first time right, I think they mean when the mission is, for example, human life, or when there is something that can never be undone, we cannot make a mistake. That's different than saying everything has to work on the first try. If you ever go that way, you will never be able to achieve cutting edge technology. You will become so risk averse that you will never try something new. Today, when we do the way we go about it in Mynaric is we iterate at the subsystem level. We try to get hardware, just like I said, like we did in SpaceX, also in Mynaric. We try to get hardware in our hands as early as possible, put it through its paces, and fail fast. And for every failure, you have learned 100 things that did go right and some things that did go wrong, and you just iterate until you come to a product. And that's an important part. 100% analytical doesn't work. 100% trial and error doesn't work either, but you have to find the right balance. Sure.
Last question about SpaceX, then we leave the past where it belongs and go to the future. So why did you leave SpaceX?
I think it's an amazing ride. I joined in 2004, and except for a small period in the middle, I was involved in there until the end of 2017. So I saw the company grow from, I joined in when I was first started. The company was about 40 people. When I left, it was about 7,000 people. It had put itself in an amazing spot, and it felt like I could have an impact outside that was more pronounced. I wanted to, I saw companies emerging. I saw technologies emerging outside of the SpaceX ecosystem, and that's an amazing one. But the outside, there were also things happening, and I said I could make an impact there, and decided that I wanted to be involved in a few more companies, and that was a decision. I got to be very honest. I still see the successes, and I root for SpaceX every single day. That's part of my life. That's what I got to build. And there's nostalgia whenever I see a huge success, like putting humans in space or bringing them to the ISS. That is excited about it and feels that nostalgia. But today, I'm super excited about what I've found out there. And when we have other cutting edge technologies like optical comms to be involved in.
Wonderful. Thank you. Mynaric, let's talk about your company. So give us a little lowdown on what you do. You hinted at it already. So it's the communication business. So let's talk a little bit what you do exactly.
Absolutely. So Mynaric is about a 12-year-old company. Our founder, Joachim Horvath, he came out of the German Aerospace Center around this idea of optical communications and that being mass produced, and founded the company in Germany. I joined about 3.5 years ago in 2019 as the CEO, and it's been a scalability sprint since. We've grown quite a bit. I had quite a bit of commercial successes in what we do. To talk about what we do.
Optical communication, is that what fiber technology does? Is that also optical communication, or do you do different things?
Exactly. So let me tell a little bit about what Mynaric does and what the technology is there for.
Sure.
So when you talk about satellites today, you think about an object flying in space in an orbit, and what they can do is they serve the people and ground stations and whatever there may be right below them. Satellites in itself are very unconnected. So meaning they don't talk to other satellites, at least not very often. There are some older satellites that had maybe a couple of megabits connection here and there with each other. But when you think about the space vehicles, they are not networked with each other. What optical communication does is exactly change that. Optical communications, and what we talk about is it's called free space optics. What it does is what we do on Earth by laying fibers and connecting switches, for example, together. We do that in space with lasers that we just shoot free without any cables between the satellites, and we can suddenly push tremendous amounts of data between satellites. To really picture it, what we do is we install what's called an optical communications terminal on a satellite. And that terminal has a small telescope opening about 8 centimeters in diameter. And what that does is send a really thin laser signal over vast distances. And that light travels up to, for example, 8,000 kilometers and hits another 8 centimeter opening on another satellite with our optical communications terminal there.
No.
Yeah. And that laser carries, just like in a fiber cable, the information. And therein lies the difficulty in what we do, and why optical communications until recently was a very, I want to say, not widely used technology, because doing that level of control, that level of accuracy, being able to send a laser 8,000 kilometers away from one satellite that is traveling at 28,000 kilometers an hour to another one that's traveling at 28,000 kilometers and hitting with a laser an 8 centimeter opening, that was not either possible or attainable.
That's pretty fascinating. I mean, like, seriously, 8,000 kilometers and you hit such a spot. I mean, like, how do you calibrate something like this? This is mind-blowing.
So overall, it's an active system. what we do is we send a laser, and let's face it, the other satellite is sending us a laser too, because they are sending, it's a bidirectional communication. And that light coming from the other satellite allows us to find out where that satellite is. And it's they both use each other's incoming communication to find the other object and track the other object in the sky. There are many difficult parts on doing that because, let's face it, these satellites aren't perfectly still either. There's some amount of micro vibrations trying to always get you off target. Even a tiny bit of mistake in angular in 8,000 kilometers becomes almost kilometers of mistakes. So that's so you have to fight against that. But there's also thermal effects that constantly take the satellite out of shape, even in the tiniest amount that we have to compensate for. So there's many difficulties there. And one of the difficulties, of course, is you never know perfectly where the other satellite is. So when the satellite that you are on tells you to talk to another satellite that it thinks is over there, you only know it with a certain accuracy. We need a much higher accuracy. So we have to search for that satellite. So that's called acquisition phase. And being able to do that in a few seconds, find that satellite and then lock onto it, not easy tasks.
Fascinating. I mean, like I'm speechless because that level of precision, I can only remotely try to understand what that means. So is there do you work with different brands of satellites here? Because I mean, are there satellites you'll prefer working with because they hold still, they don't wiggle so much? And are there other brands that you would refrain from working with?
No, I think we want to be a merchant supplier to everyone. And that's a big part of the value add of Mynaric. Besides being mass manufactured and affordable, one of the things that we have really done with our design is a optical terminal that can really take more micro vibrations than some other laser communication terminals out there. That means that the satellites that we are on can be a little bit rougher in flying, which is important for our customers. Let's face it, they don't want to buy an optical communications terminal. Sure, we made it cheap, but then if you go to them and say, no, but you have to buy the best satellite out there and spend 100 million euros just to be able to fly this optical communications terminal. Sure, I was cheap, but the end effect was expensive. That's the reason why we have designed our terminal to be able to fly on many platforms, pretty much any platform within reason. And that allows our customers not only to save costs on their mission, because we are cost effective, but also because we can fly on cost effective satellites.
So who's your typical customer?
So the typical customer base is quite wide. Today, our main customers come from the U.S. government segment. We have quite a large presence in the U.S. because the U.S. DoD and their partners have been looking into satellite constellations for a while, and they are an early adopter in optical communications technology. These are mostly constellations of small satellites. And when I say small satellites, I'm talking about 200 kilograms and whatnot. So I'm not talking CubeSats, but about 200 kilogram range that build Earth observation or communications constellations, in this case for the government use. That being said, the bigger customer base on the commercial side is, of course, the broadband constellations. The companies like the potential customers where it will be Starlinks and Kuipers and OneWebs and Telesats and all these other communications constellations. We look at their business plan, and they all say the same thing. For the constellations to really make sense, they have to be these satellites have to be networked with each other to really build a true mesh network in the sky. Sure. And that's our main application. But it goes from there to a very wide other use cases as well, from live Earth observation, where all the Earth observation satellites are connected with each other, such that you don't have to wait 45 minutes or an hour until you get your image, or space relay systems, which allow single satellites to be always connected. So the use cases are quite vast.
Fascinating. So I guess that constellations like we already talked about Starlink, how do those Starlink satellites communicate with one another? I assume that goes via ground stations on Earth, and then that goes back, and you would have a solution where those guys talk to one another while in orbit.
Correct. So it's optical communications technology is complementary to the radio communication that we have today. All these satellites will have radio communications to their users. They will have radio communication to their gateway. But when it comes to pushing data from a communication from A to B, if A and B are far apart from each other, that requires multiple hops, and it's better for the satellites to do that in space rather than constantly go up and down and up and down. And it results in lower latency. It results in much better use of bandwidth. It results in a closed network, more secure network. And not only that, there are places where you can't have a ground station, like in the middle of the ocean. So if you want to serve a plane in the middle of the ocean flying, you need to be able to serve it from a satellite that may not be able to see a ground station at that point. So it needs to communicate via optical to neighboring satellite until it finds a ground station.
So I guess your technology is applied to new satellites. So I guess there's no way to equip older satellites already in orbit with that technology, or is there any need for that in the first place anyways?
I don't think so. I think there is really no need to equip older satellites in orbit. Let's face it, we see the deployment speed of satellites increasing rapidly. Yeah. Just in 2019, we had less than 2,000 active satellites. We are already approaching 5,000 here in just short 2 years. So overall, the future deployments are what we are looking at, and that is the growth. That's the growth side of the satellites, and most of the satellites in orbit aren't really made for digitally routing data around. Anyways, it's these new satellites that can do that, constellation satellites. So that's our beachhead market in the space side.
So can you give us, for a layperson like myself, give me an example what makes a satellite with your technology better, or a constellation better and more useful than it's right now without it?
Well, there was the example that I just alluded to, which is, for example, the airline example. We have quite a bit of trans-Pacific and transatlantic flights. And when you want to have connectivity on a plane like that, you have to talk to a satellite that's just right above you. It's flying really low. For example, the Starlink satellites are about 500 kilometers in altitude. That means if it's seeing that plane in the middle of the ocean, it is not seeing any land. So it needs to be able to somehow get the data to wherever that it needs to go. And for it to reach that, it has to somehow hand over the data. If I'm, for example, let's take the example of me flying from LA to Kwajalein. It needs to somehow take the data east over multiple hops over satellites before that data can find its way to, for example, a Netflix server. So our optical communications allow that. Without an optical communication, that satellite over a unpopulated area, maybe the desert or ocean, or maybe even an island, may be completely unusable. So it's not generating any revenue whatsoever. And secondly, even if I'm on over a landmass, and I'm talking about the Los Angeles to London communication, for example, you wanna, as a satellite operator, avoid having to take the data from the Los Angeles user and send it right back down to the ground, and then use ground infrastructure to carry that data all the way back to London. Because let's face it, you don't own that ground infrastructure. That means you're paying someone else to do your work. And that is a cost to your constellation. If you can use your own closed network to bridge the traffic from Los Angeles to London, that is the better solution and the more cost-effective one.
Where is Mynaric headed? So what's the vision for the next years? Where is Mynaric in 10 years?
So let's talk about the next couple of years. For us, it is very important that the optical communications technology arrives at all satellites. We believe that satellites and the space industry is going to have a quantum leap in usefulness by the incorporation of optical communications technology. Just like computers increase their usefulness by multiple folds by being networked with each other. In the old days of workstations and whatnot, when they were singular units not connected, they had limited utility. Only when the internet came did their utility go into every single industry, every single person. We will see the same thing for satellites with the optical communication side. So our first job is to make sure that we make this technology scalable, affordable, available, and easy to use. And that's exactly where we are today. We have opened up the world's first serial production site for optical communications terminals. We are already signing contracts with price tags for these terminals that beat the old prices by orders of magnitude. So that is the job that we have to finish. This is a job that we started. We are well underway. We have already shown successes and that we can do it. We have to scale it up, and we have to make sure that Mynaric is a company that is delivering thousands of these units a year. From then on, I think Mynaric has multiple opportunities, maybe by the fact that we are a tremendous optical company that allow us to do things. There is other pieces of hardware that are near our optical communications terminal that could be of interest to us. But first, our focus, and it's very important, that's something I learned at SpaceX. In these years, it's so important that the company keeps focus and doesn't stretch itself thin.
Sure. You know what? It's fun to see that you are producing a solution to something that on Earth we're not ready to produce, because we have cars, and those cars do not talk to one another. So it's pretty much the same. So it's kind of funny to see that a solution that could have been happening for cars for a couple of years now is being deployed in space. That's kind of interesting.
Fair. I think that's a fair observation. But of course, one of the things that we have to also realize about satellites is they are telecommunications hubs. So not making them networked really reduces their utility. So we have to get this step done.
Yes, absolutely. Absolutely. Wonderful. So we have an interesting question from one of our listeners here. And Valentin says that we see an almost exponential growth of constellations in space. Do those constellations have any kind of worst case security system so they don't bump into one another?
So there's multiple answers to that, in multiple ways. Constellation operators are making sure that they are being good stewards of the orbits they are in. First of all, of course, these constellations are deployed at different altitudes. When you apply to the FCC or the ITU, they are not just looking at your frequency allocation, they're also looking at your orbital plans, and they want to make sure that you have a good plan in place for not causing any collisions. One of those plans involves that each one of these mega constellations settling in at a certain altitude with a certain amount of separation. So that allows these constellations to not be in constant conjunction with each other. That's the first level of defense. The second level of defense, of course, is active monitoring. There are many entities out there, both governmental and commercial, that track all these space objects in the world to make sure that they are well cataloged and their orbits are known. And what they do is they propagate these orbits forward and look for potential near misses days in advance. So when you are operating a constellation of hundreds, if not thousands of satellites, you get an update from these entities saying there is a conjunction, which is defined as two satellites coming less than a few kilometers near each other. And then you have that time, or those 2-3 days of time, to do a maneuver to actually get rid of that conjunction. Besides that, of course, there is automation that plays a big role in satellite operations today, because we're not talking about 2, 3, 4 satellites anymore. We're talking about thousands. So this type of input is very often automatically responded to. Does that whole system need more innovation and more work? Yes, we need to automate the collaboration between companies. There have been incidents of miscommunication between companies and whatnot. We have to increase the accuracy of tracking, but overall the systems are in place.
So yes, and there's another super interesting question. And that is maybe also pretty much related to that communication that you're offering with Mynaric. Does this help make the satellite industry maybe even more to be more sustainable, because sustainability is like all over the place. So is this also something that is on your table, an issue that is on your table that you're trying to solve? Go ahead.
Absolutely. Yeah. This is definitely something that we work in Mynaric, and what our optical communications terminals enable. When you're deploying a satellite, you're deploying it at the end of the day to give users bandwidth. Whenever you're using that same amount of spectrum for other purposes, gateway links to constantly bounce the data up and down and whatnot, you're not utilizing the bandwidth to serve your users. So for the same amount of users, you need more satellites to be deployed into orbit. What optical communications does is leaves the whole radio spectrum for you to use for your users, while we take care of the backhaul without requiring any spectrum, and therefore decreasing the size of the constellation for the same amount of work. So there is that sustainability factor in itself. Also, if you think about it, the size of the satellite is very much driven by the power consumption. And when you think about the fact that optical communications today, for the same amount of power, can send 100 gigabits across from one satellite to another, where with the same amount of power, radio frequency could probably send a few megabits. You see the difference in utility, and once again, that turns to sustainability.
Great, awesome. Let's jump back in time to the very early days, because we're getting close to the end of our beautiful conversation. So I guess you've always known that you wanted to be in the space industry, even during kindergarten, right?
Correct. There's a good anecdote there. Yes, I do still have my kindergarten diploma. On it, it says loves building rockets. So yes,
is that serious?
That's serious.
That's pretty cool.
Yeah, and I still appreciate that. I love rockets, planes, everything that leaves the ground. Always had a big place in my heart. But apparently, rockets was where it was going to start, and satellites was where it's going to continue. So yes, the fascination was always there.
Wonderful. We have a beautiful tradition at the end of our show, and that is we ask the question, because this is a space cafe, a coffee place, we would love to have an espresso. Espressos energize the mind and the body. So why don't you give us an espresso for the mind now? You can pick whatever kind of topic you want to pick something that could be an inspiration to our audience.
I think I would like to return back to the comment I made about computers being networked. Let's face it, we are once again at an industrial turning point. And so far we had a space industry that was limited in its utility because of the connection problems between the different space vehicles we have out there. And when you think about it, this technology being able to communicate between satellites, between space vehicles, could make the same amount of forward leap for the whole industry that the internet did for consumer electronics and computers.
Wow.
And now I want to take the science fiction jump to it, just to really energize everyone. One of the things that we always see in science fiction is two spaceships, whatever it may be, if you're a Star Wars or a Star Trek fan, they come near each other and then they start establishing communication. I can see that being done over radio. And actually, if you watch The Expanse, like I love it, or read the books, you realize that there is this concept of tight beam. And that's exactly what we built. We built tight beam communications that you can build ad hoc. And I can already see where this is going, that this is going to be one of those enabling technologies we're going to look back onto. And we're going to make science fiction into science reality, because anytime, any place, you can do a connection between two objects that doesn't require any spectrum, any regulation, any approvals, and works just perfectly between two locations. I'm quite excited about what the impact could be.
You're getting me excited. This is very, very, very uplifting. Bulent Altan, thank you so much for taking the time today. That's really inspiring.
Thank you, Marcus. I really enjoyed being here and having this conversation. And thanks to your audience.
thanks for being there. We're insanely happy for your loyalty. It means a lot to us and motivates us to work even harder on ourselves and the podcast. You can support us the most if you tell others that you like the Space Cafe podcast, and also, of course, if you leave us a review on iTunes. We look forward to next time. P.S. Don't forget to check out SpaceWatch.Global. Not only if you're a Space Watcher already. Bye-bye. Take care.